Okay, multiplying special cases. We can multiply we can multiply these binomials the same way we did in the previous section, but when we start to learn to, or we're able to recognize these special rules, well, it makes it easier for us as if we can recognize them, it makes us easier to see the pattern and answer the question much more quickly. And what we'll talk about here more specifically will be the square of a binomial and the difference of squares. So a square of a binomial could simply be, that's pretty poorly written there, a plus b squared, and I have a binomial that is squared, and that is the equivalent of a plus b times a plus b. And when you do your FOIL method, or any of the methods that you do and you go to simplify that, what you end up having is a squared plus, so you have your a times a, and then you have your b times b, and we're going to have plus b squared, and then in the middle there we're going to have 2ab, because we would have multiplied a times b and added it together. Therefore, we get in 2. And then we'll practice this, but there's that pattern that gets formed. And then the other special case would be the difference of squares, where I have possibly a plus b times a minus b. And that is the sum and difference there that we're multiplying together. And what you end up having is, well, you do get your a squared, and you do get your minus b squared, but when you multiply the inside, you get a times b, so you get plus a times b, and then when you multiply the outside, you get a minus a times b, and then these two things end up becoming 0. And that is that special rule that you'll see, and it ends up becoming a squared minus b squared. So it's if you can recognize the difference of squares, it becomes very simple to go ahead and multiply that out. So given that, as we talk about these special cases, talking about squaring a binomial, and I've already shown you that example up top, where x plus 8 squared is going to be x plus 8 times x plus 8. When we do the whatever method you use here, it looks like I've used the FOIL method, where I have the first x times x plus x times 8 plus 8 times x, and then plus 8 times 8, which gives me, when I combine all my like terms and multiply everything out, x squared plus 16x plus 64. And as you see up here, right, I said that you're going to have 2 times a times b. Well, in this example, my a is x, my b is 8, so that would be a times b would be 8x, and then 2 times that would be 2 times 8x is 16x. So there you have it. 8x plus 8x would be 2 times that, giving me the 16x. So being able to see that pattern forming. And then, of course, I've done the difference. And what I've done here is the same thing, where I've written it out. And I've gone and multiplied my 2m times 2m minus 3 times 2m minus 3 times 2m minus negative 3 times negative 3, which gives me the 4m squared minus 6m plus 9, and then I've simplified it here, combined all my like terms. And again, you see I have a 2 times a times b. And we can go ahead and do the multiplication here on these next two examples. And we have n times 7, n minus 7 times n minus 7. So we're going to have an n squared, right, because we're going to do our firsts, right? We have n times n. Then we're going to do our outers, which is going to be n times negative 7. So that would be minus 7n. Our inside, which is going to be negative 7 times n. And then our outside, which is going to be negative 7 times negative 7, which is a positive 49. Combining like terms, we still have n squared minus 14n plus 49. And there you go, we have been able to do that. Let's see, moving forward, next example, we have 2x plus 9 times 2x plus 9, right? So again, and if we use the distributive model here, so we know we have to multiply 2x times all of that and 9 times all of that. So I have 2x times 2x plus 9 plus 9 times 2x plus 9, and then when I go to do my distributive method, I get 4x squared plus 18x plus 18x plus 81, and that becomes 4x squared plus 36x plus 81. There you go. So using those special, these rules are the same rules that we were using before in this type of structure. We've been doing this all week where we're multiplying a binomial. Now we just happen to have special binomials that we're multiplying together. Okay, so moving on here, as we look at this, when we apply squares of binomials, well, it says a square outdoor patio is surrounded by brick walkway. And then what is the area of the walkway? Well, what I've done is I've given you a little drawing here. So I need you to assume that this area in here is going to be my patio. Right in here, patio. And then the 3 feet is going to be my walkway around my patio. I'll even do that. That's my patio. Okay, so and what I've done here is I've said, okay, well, if my patio is some length of x, and I have it labeled here, but it's a little bit hard to see, x times x, and then I know that this distance right here is going to be 3 feet, and because it's going to be 3 feet all around, and this distance is going to be 3 feet. So I end up having, when I look at this entire length right here, I end up having the value of x, and then plus 3 feet here, plus 3 feet here, so that's where I come up with the x plus 6 feet, and then it's square, so I end up having the same here, x plus 6 feet, and it says, what is the area of the walkway? Well, what is the area of the walkway? How can we figure that one out? Well, we know that the patio area, well, we need to know that area is going to be length times width. And the patio area is going to be a length of x times x, which is x squared. And then I know that the overall area, including the walkway and patio, is going to be all of it. I'm just going to put all of it, right? All of it is going to be x times 6 squared, or should I say, I'm sorry, x plus 6. X plus 6 times x plus 6, which when we multiply that out, that becomes x squared plus 12x plus 36. Did I go too fast for you? Let's see. X squared plus 6x plus 6x plus 36 is x squared plus 12x plus 36. Okay, so that's the whole area. And then if we want to know what is the walkway here, well, what we can do is we can take the entire area of the patio, or the entire area of the outdoor area, and subtract the patio from it, and that will tell us what was left in the walkway. So I have my the area minus the patio. So I have the area is x squared minus 12x plus 36 minus x squared, and that is going to simplify down to, 2x, or x squared minus x squared, so we're going to have a a positive 12x plus 36 is going to be the area of the walkway. By taking the entire area and subtracting the patio from it will tell me what is left in the walkway. And if I look here, this next example, it says, suppose that the brick walkway is 4 feet. Well, if I turn around and say that this is 4 feet, I have a patio around here 4 feet, well, my new patio is going to be, or the entire area is going to be not x plus 6, but it'll be x plus 8. The area of my patio remains the same. So when I multiply this out, I have x squared plus 8x plus 8x plus 64 minus x squared, and x squared minus x squared will cancel out, and then therefore I end up with 16x plus 64, and that is the area of the walkway. There you go. So I took the information that I did know, came up with a polynomial, and then subtracted the information, and came up with the two formulas here for the area of the walkways. And then finally, going here, this next, see, it says find the product of the difference of squares. And then we're going to go ahead and find the simplified form here. And here is what, because of the pattern that you're going to start to see here, is the difference. The only difference between these two binomials is going to be the sign. So we have the sum and the difference. And what happens here is when we do the FOIL method, we're going to find out, or any of the methods we choose, we're going to find out this is a positive 9x, and then when I do the outer, I'm going to get a negative 9x, which in turn is going to zero out. So looking at this example, when I do my methods here, whatever method you choose, I'm going to have x squared plus 9 times x plus x times negative 9 plus 9 times negative 9, which turns out here again that when I combine like terms, 9 minus 9 is going to give me a 0. So I end up with x squared plus 0x minus 81, or simply x squared minus 81, seeing that those two things are going to zero out. So using that, we can go ahead and I see here that I have the difference of squares. I have 6 plus m squared and 6 times 6 minus m squared. And we can do it, all multiplied out. So I have 6 times 6 plus 6 times negative m squared plus 6 times m squared, and then plus m squared times m squared, and that will come to 36 minus 6m squared plus 6m squared plus m to the fourth, because remember when we're multiplying like bases, the exponents are added together. This becomes 0. 6 minus 6 is 0, so we end up with 36. Sorry. One of those is a minus, so I lost my sign there and shouldn't have. 36 minus m to the fourth. So seeing the pattern that we have 3c plus 4 times 3c minus 4, we have the difference of squares. And when we have the difference of squares, you'll notice that my what would have been associated as my b term zeroes out, and we end up with just a squared minus b squared. So if I look at that, that gives me a squared minus b squared. So I have 9c squared minus 16. There you go. And that's how you can quickly do, when you recognize the pattern of the difference of squares, come up with a very easy answer. And that was much easier to do than all of that over there, because I practiced and I recognized that pattern. So again, we can always use our old methods of multiplying polynomials, but if we can recognize these patterns, and we can recognize when we see certain things, the difference of squares, a perfect binomial square, it helps immensely. And then as we get that practice too, it's going to help us factor more easily in the next couple of units, because being able to recognize the result will allow us to turn that back into the binomial very easily. So, and good luck with this lesson, and we'll do some more practice.